Hello everyone. Please don't forget to subscribe to our channel, also like and comment. So today we'll be dealing with Euclidean geometry, but focusing on similarity and proportion. So let's do this question together. Let's do this question together. Here's our question. They said, could two circles touch each other internal at point B? O is the center of the bigger circle, lies on the circumference of the smaller circle. Okay, it means O is the center of the bigger circle, also the circumference of the smaller circle. Okay, FBG is a common tangent. Okay, it means it is the tangent of both of our circles. And then they're talking about the chord. That's useless information. So let's read the last statement. They say AH is to AG is equals to 1 is to 2. Ne? Okay, yeah, that is one of the useful information or important information. Ne? So let's go to the questions. Firstly, when you're answering Euclidean geometry, you must first read the given information. Ne? Don't jump to questions without reading the information above. Okay, so the first question, they say give a reason why angle B4 is equals to angle HCB. Okay, before I answer this question, there's another information that they have left behind here. So if you can check, we are given two parallel lines. So they were supposed to write HC is parallel to it is GF, ne? Yes, they were supposed to write that information also, but it's fine. Just because they have indicated it, it's fine. So if you can check, our angle that they're talking about, it is this one, angle B4, and the other angle, it is angle HCB. That's the angle C. Ne? So always when you are given parallel lines, you must think about three things. Ne? When we are in Euclidean geometry, we think about corresponding angles, alternate angles, and also co-interior angles. Ne? Yes, but when we are in analytical geometry, you can talk about the gradient, because the lines that are parallel, they have the same gradient. We apply those rules in analytical geometry, because in Euclidean geometry, you will not be asked to calculate a gradient. So yeah, here we talk about the angles, alternate angles, vertical, not vertical, I mean corresponding angles, alternate angles, and co-interior angle. So these two angles form our Z shape, which is alternate angle. So they are equal because of alternate angles, because we have two sides that are parallel, the HC and the GF. Okay, let's go to the next question. It only had one mark. Then prove or give a reason why angle B4 is equals to angle D4. Okay, angle D4, it is this one. We are still talking about the very same angle B4, but now it is equals to angle D4. So don't forget, our angle B4, it lies on a tangent. Ne? So always when you have tangent, you must think about the tan perpendicular to the radius or perpendicular to the diameter. Ne? And also think about the theorem of tan chord. So here, angle D4 and angle B4, they form a tan chord theorem. I hope we all remember a tan chord theorem. Ne? So we'll come and write tan chord theorem. That's the reason. Let's go to 10.2. 10.2.1. Prove that triangle, it is triangle DBE, ne? It is similar to triangle DBC. So to prove a similar triangle, it's very easy. You must prove this angle D in triangle DBE is the same as angle D in triangle DBC. So let's go ahead and check. Are they equal now? Angle D in triangle DBE, it is, let me erase this thing first. Okay, angle D that they are talking about is in triangle DBE. Oh, it is D4. Okay, it means they are talking about D4. Let's check another, or let's check angle D in triangle DBC. D that they are talking about, it is D3 and D4. Okay, which you can write as B, D, and then C, still the same. We're talking about angle D3 plus angle D4, right? Yes. I think there's a mistake in this question. It is impossible for angle D4 to be equal to angle D3 plus D4. This statement doesn't make sense. It's like when you want to say, okay, 2 is equals to 2 plus 3. Like, is this possible? No, there's no way. So I think the person who said this question made a mistake, or maybe it didn't put these things in order, because in similarity you must be very, very careful. You must put these things in order. And if they are not in order, you're going to have a big problem. So let me erase that D. No, let's check. Okay, or let's do it like this now. Let's check an angle which is equals to D4. All right. There we were given, or we proved that B4 is equals to angle D4. This is the angle that I know it is equals to D4. We have proved it in 10.1.2. This one was said good Tancourt theorem. I hope you remember that one. And the angle B4, is it in a triangle that we are talking about? No, it is not on the triangles that we are talking about. So let's continue. Let's find another angle maybe which is equals to B4, and we have the information in 10.1.1. B4, it is equals to angle C, or HC. It was HCB. It is, we have only one angle in C. We don't have C1, C2, so I can also write C only. It is still fine. All right, so let's go. Okay, see this C, it is in the triangle that we are talking about. One they have written it is DBC. So yeah, it means here, let me write it in with another color. Here we're supposed to be C, not D. They have made a mistake. They didn't put them in order. So yes, so because look, D4 and C, they are equal. Angle D4 is equals to angle C because they are both equal to angle B4. So you can also indicate by this thing. We have proved the first part. This. Okay. We must also find where B is equals to B. Let's check the B in triangle DBE. All right. DBE. It is B2 and B3. Right. Okay. Perfect. Let's also check the B in triangle C. Okay, I will call it CBD instead of DBC, but it is CBD. It is very important to put these things in order. Okay, let's go. CBD. Oh, it is the very same angle, you see. It is the very same angle, so we can call it maybe a CBD angle B. We're talking about angle B2 and B3. Okay, it's common. It's common. This one is a common angle. So yes. All right, the last one, it is angle E and then angle D. You must also prove that they are equal. Then angle D, no, okay, let's start by angle E. Angle E in triangle DBE. DBE, oh, it is E2, okay, right? Okay, right. Angle E2. Angle E2 is equal to which angle here? Or equals to angle D. D, it is that D we have talked about in the beginning that we said, no, it cannot be equal to D4. It was D3 and D4. Okay, I can call it BDC because, yeah, that's the angle that we talk about. So the reason here we can write third angle of a triangle. That's our reason. You don't write third angle of a triangle anyway, right? It's only when you're talking about or when you are proving a similarity. Yes, not always. And you write it in the last angles that will be proving with. The first two angles must have a reason. Then maybe the last one you can write third angle of a triangle. You don't have to start, or you cannot start with this one and say E2 is equal to angle D, and then you write third angle of a triangle, and then in this other, or in the following step you prove the other angles. No, it is wrong. This one must always be at the last, or at the conclusion. Then we have proved good triangle DBE. It is similar to triangle CBD, not DBC. They have made a mistake there. Then angle. Then we're done. And another thing that you should remember, similarity can be proved in two ways. It's either we use angles to prove the similarity, or we use the corresponding sides. If we find the corresponding sides are in same proportion, it means those two triangles are equiangular. Equiangular means they are similar. All right. Okay. We are done. Let's go to 10.2.2. Let me erase everything that I have written here. You can pause the video and copy everything. It's not a problem. Let's just try to be fast, Jan. Let me try to be fast. I don't want this video to be a long video, okay? Because you will end up losing concentration. So I want it to be short, less than 30 minutes. Then let's go to the 10.2.2. Prove that D is the midpoint of AB. If D is the midpoint of AB, it means we must prove that AD is equals to DB. That's it. Because this is the line A, then here we have D, here we have B. So if we have proved this length and this length are equal, AD and DB are equal, it means that D, it is the midpoint of AB. That's how we prove. So in maths is very simple. You just need to know how do you answer this question. You see, because you cannot answer this question if you don't know what to do or how to answer it. You see, so this is the way that we should prove correct. D is the midpoint of AB. We must prove correct. AD is equal to DB. All right, and we're given a ratio here. So yeah, we have been given a ratio. Let me try to draw this triangle here. Okay, there is parallel lines. Then A, it is H, it is G. A, and then this is D, this is B. All right, let me erase this. Okay, so let me edit all the information you've been given. AH is 1. Mind you, that one, it doesn't mean the length. Ratio, it doesn't mean it's the distance of that side. So I can write it as A or B or K. Then and also given AG, okay, it is 2. Can write 2A. Then the other one, obvious, it will be A. I hope you understand that one. Then here you see you have a line drawn parallel to one side of a triangle, and if a line is drawn parallel to one side of a triangle, I hope you know what to do. Obviously, we're going to apply a proportion theorem. Okay, let's go. And we have to talk about AD and DB, don't forget. So we'll say AD over DB is equals to AH over HG. Our reason here, it's line parallel to one side of a triangle. I hope you know this reason by now. Then it is AD over DB, which is equals to, this thing will give us 1, because A over A, or 1 over 1. So let me write 1 over 1 is fine. Then let's cross multiply. Obviously, AD multiplied by 1, it is AD. DB times 1, it is DB. Perfect. So we have proved these two sides are equal. All right. Then we have a midpoint theorem. I hope all of you know midpoint theorem from grade 10. And you also did it obviously in Euclidean when you were learning Euclidean. Then let's go. We have proved, so we can come and write that D is a midpoint of AB. Here's our reason. Converse converse midpoint theorem. Ne? That's our reason. Then we are done. Let's continue. Let's continue with another question. You can pause the video and copy everything. Ne? Yeah, you will forgive me, I don't have enough space. Even if I try to scroll down, I will no longer see the question. That's why. Ne? I can be able to add another page, but the problem is that I can't see the question anymore. So I want to answer everything seeing my question. Ne? Yes, so that it can be easy for me. Then we have to prove group AB squared over 4, it is equals to BC multiplied by BE. Then don't forget we also had the triangle BDE. It is similar to triangle CBD. Hey, writing them in order is very much important. You're gonna see here. Ne? So, okay, look, we talked about, or they want us to talk about BC, and we have BC here, you see. All right. Okay. Oh, sorry. I pointed DC instead of BC. Sorry, let me fix that mistake. All right. All right. We have BC. Yeah, this one. They want us to. So if we talk about BC in this side, here we'll be talking about BD because it must be in order always. Then they also talk about, let me change a color. BE. Do you have BE? Oh, BE. Do you see BE? It means in the other side it must be CD. Or am I correct? Yes. Or we can say DC. Ne? Yes, I think I didn't make a mistake when writing this thing. I have written it in order because if they are not in order, I'm gonna have a big problem. But I think I've written everything in order. Is it BE will go with DC, right? Let me check very well. BE. Oh, I didn't write it in order. That's why I was not getting the correct things. So it was, it is, oh, DBE. Oh, sorry guys, I made a mistake. Similar to triangle. That one I said with CBD. Now we're gonna do the right thing. Sorry for that. We talk about angle, not angle side, the BE. I'll start with BE this time. BE, do you see BE? It means in the other side it must be BD. I hope we are still together. They also talk about BC, okay? Oh, because of why am I always making mistake here? Let me use this card. BC, do you see here? It means in the other side it must be BD. So let's start. If we start on the left hand side, always we must make sure our left hand side it must be the numerator. And if maybe we make our numerator to let me show you what do I mean. Well, baby, oh sorry, BDB over BC, right? I hope we are still following. Because I started at the left hand side, I must also start the left hand side. Is equals to BE over BD or DB, still the same. The reason is this one, similar triangle. It is important to write the reason. Don't just write this thing without the reason. Then let's cross multiply DB times DB. It is DB squared equals to BE times BC times BE. It is the very same thing that we are having here. So it means we must express or write DB in terms of AB. Ne? So, okay, DB, it is half AB. Reason, we can write, this is our reason. D is the midpoint. D is the midpoint of AB. You will come and write it there. It's very much important. Very much important. Look, guys, let me show you. I know some of you might be asking how we are having a line. It is A, then in the middle we have D, here we have B. They say these two sides are equal, so it is AD plus DB is equal to the whole of AB. I hope that it's clear. Then don't forget AD, it is also DB. So DB plus DB, it is 2DB equals to AB. Hope you are still following. Equals to AB. Then we're going to divide everything with 2 there. DB is equals to AB over 2, which is the same as half AB. I hope you all see. Right. Let me try to be fast here. I'm saying. Okay. Then okay, I have proved that. So where there is DB, I'll just go and substitute this one, half AB or AB over 2 from here. Let's start. AB over 2. It was DB squared, so I will also have to square this thing. It was to BC multiplied by BE. So AB times AB squared. 2 times 2, it is 4, equal to BC multiplied by BE. We have proved. We are done. 2 questions left. Only 2 questions left. I hope you are still with me, guys. Please, you can pause this video and copy everything here, or screenshot it. But I will advise you to pause the video and write it down so that you understand, because you'll be having the notes or having the workings in your book, so it's gonna be simple. But if you just screenshot, the pictures will be in color, and after the video you'll be maybe lazy to copy it. So I will advise you to be writing also and understand. Then for more, you can join our online classes. We have online classes for grade 8 to grade 12. I'll update you more about my classes after the session. Here we are given that CE is to BC is equals to 5 is to 9. Oh, we must prove this. We are not given. Okay, they have to prove this thing. If what? If they have given us correct, DB is equals to 3 units, and then BE, it is equals to 2 units. Okay, all right, cool. Don't forget, in the previous question we were having something like DB squared, right, is equals to BC times BE. I hope you can all remember that. So where there is because now to prove this one, to prove that question, you have to find the value of CE and the value of BC. So we can find the BC using this thing. Where there is, let's substitute, where there is DB, it is 3. You can see there 3 squared equals to BC multiplied by BE, it is what? 2, isn't it? Yeah, BE, it is 2. We have to divide everything with 2, or before that, 3 squared, it is 9 equals to 2 BC. Then we can divide everything with 2. BC will be 9 over 2. I hope you understand that one. We have to find the value of CE now. So CE, it is simple. CE plus what? BE. It gives us the whole of AB. The whole of BC. Yes, the whole of BC. Sorry. Because it is like this. We have C, we have E, we have B. So CE plus BE, it gives us the whole of BC. That one needs a general knowledge. The CE plus, we have BE, it is 2 equals to 9 over 2, because BC is 9 over 2. We just calculated it. CE is equals to what? 9 over 2 minus 2. It is 5 over 2. All right, now we have CE, we have BC. We can calculate, or we can prove that ratio. We have to prove. Let's go. I'm gonna show you how to prove this. Don't forget, this is the same as CE divided by BC. CE, it is 5 over 2 over BC 9 over 2. Mathematically, these two can be divided with that 2, so that you'll be left with 5 over 9. 5 over 9. But let me show you how, because I know some of you might be asking, is it legit? Here it is, 5 over 2 divided by 9 over 2. 5 over 2, the reciprocal of division is multiplication. The reciprocal of this one is 2 over 9. Then 2 and 2 will divide each other. You'll be left with 5 over 9. That's what I have here, 5 over 9. So, indeed, the CE is to BC. It gives us what? 5 is to 9. Proved. I hope you are still following. Then let's go to the last question. This is our last question. Then yeah, I hope you guys are still enjoying the video. Okay, and then here it is. We have to calculate the ratio of area of triangle AHD divided by area of triangle HGB, right? Do we have triangle HGB here? No, they have made a mistake. Hey, this question paper seems like it has a lot of mistakes. If I've seen it, I would have changed the question paper. It's just that I didn't do this question paper before, but it's fine. You can fix it. It was supposed to be AGB because we have triangle AGB here, not HGB, you see. And then it was a small mistake. Then let's go, guys. So then don't forget this side, it is equal to that side. That's what it's A and A, you remember, and we have a midpoint theorem there. Let me try to draw these things. I'm not good in drawing, but I'll try. Then this is okay. You need to know a midpoint theorem. If we are having this triangle, okay, it's fine. I'm gonna explain. Then this is A, this is H, this is G, this is B, this is D. So we can use these two sides, AH and HD. We're gonna use a sine rule, don't forget, because we don't have the perpendicular height. We're going to say half base times height, so we don't have the perpendicular height, so we're not gonna use that one. We have to use area rule, and the angle that we can use here, we can use angle H because it is also equals to angle G, right? Because of corresponding angles. I hope you can see it forms F shape. So here it is. Let me write correct that area. It is half. I'm starting by the area of triangle AHD. AHD. It is half AH multiplied by HD. Okay, multiply by sine H, sine of angle H, divided by half. Now I'm going to triangle AGB. There will be using side AG multiplied by length of GB multiplied by sine of G, or you can write sine of H because they are the same. So here half and half will divide each other. Sine H and sine G will divide each other because I told you those angles are equal. Alright, so let's check. We are left with AH multiplied by HD. So we must also express what we are having in terms of AH and HD. Okay, AG, do you see this AG? Obvious, AG, it is 2AH. I hope you can all see that. But let me write it first, so that when I substitute, it can be simple. AG, it is the same as 2AH, because AG, it is formed with AH plus HG. and this is the same as AH plus AH, because HG it is also AH, né? Perfect. So it will give us 2AH. So let's go to the other one. GB. Hey, you see this one. Let me give you an example. We have P, Q, B, and then C, and then A. If these two sides are equal, we have two parallel lines. So in this form, this is a midpoint theorem. Eh? It means BC it is equal to 2PQ. Ne? So this is the same as this one. Here, GB, it is the same as 2HD. That's it. That's a midpoint theorem. So we must also write the reason. It is midpoint theorem. Oh, sorry for that. Hope you all seen how to do this. Ne? Midpoint theorem. Midpoint theorem. Ne? Perfect. Then yeah, both of these things, they have the same reason. Then we can go and substitute AH multiplied by HD divided by 2AH. Ne? I have substituted where there's AG with 2AH multiplied by 2HD where there's GB. It's just a matter of substitution. Then AH and AH, HD and HD will be left with 1 over 2 times 2. It is 4. We are done with that question, eh? Or we are done with the whole of question paper. Then yeah, let's go to our classes, our online classes. How are they going? Yeah? So guys, this is our online sessions. As you can see, we are doing online classes for grade 8 up to grade 12. Né? Yeah. So we are using Google Meet as an app that I use to teach and also for learning. Né? Our session, it is 50 rand each for 2 hours. Then our Saturday sessions for monthly or per month, it is 150 every Saturday. Monthly session, it is 300 per month. This is every Saturday and every Sunday sessions. Né? Then for bookings, you can call me or WhatsApp me at 066 276 4810. Né? That's all about our classes. If you have some questions, you can also inbox me based on classes or based on maths, or you can send me questions that you need us to do here. Né? Yes, thank you guys for watching. Please don't forget to like and also subscribe. Né? Thank you.